This video will cover the design and construction of a prosthetic finger made mostly from trash. The design is a body-powered prosthesis meant to replace a missing distal and middle phalanx using the movement and force of a proximal phalanx stump. Although the design is based on a common concept, it is meant to be simple enough that anyone can build it with a few simple tools and basic knowledge on the subject. The measurements will be based on the little finger since it is the smallest and therefore the most difficult to reproduce. I will start by describing the general functionality and materials of a finger. Next, I will show how I got those measurements. Then I will translate that into construction, and finally I will show some options. Okay, as I stated earlier, the little finger has three bones: a distal, a middle, and a proximal. These bones are attached to each other by joints made of cartilage and ligaments. And the bones move when muscles pull on them through several cord-like tendons, which means that the prosthetic finger will need something to act as the bone, something to act as the joint, and something to act as the tendons. Bone is a heavy material with a matrix of mostly calcium salts, phosphorus salts, and collagen. In material science, this is called a composite material. So an ideal bone substitute would be a similar composite like fiberglass or carbon fiber. But with trash, the best option is to layer plastic and metal sheets together. Now it turns out that plastic trash also makes a good joint material, so it will be used for both. Fishing line will be used for the tendons, and it is not a common trash, but it is cheap, so close enough. The measurements will be using the metric scale because large fractions are a pain to deal with. For my model, I will be using my little finger in the fist position. And while approximating the centers of the joints, I can measure a 40 mm line from the proximal phalanx. Similarly, I can measure about 20 mm from the middle and distal phalanx. I can estimate the joint of the distal and middle phalanx to be a 10 mm diameter circle, the middle and proximal joint to be a 15 mm circle, and the knuckle to be a 20 mm circle. I could draw lines from each joint circle to approximate the finger height. As I mentioned earlier, the joints and tendons will be plastic, allowing them to slide over each other, while the layering of metal and plastic will simulate the rigidity of bone. But running fishing line around the metal edges will cut the lines, so plastic must also be used to protect the fishing line from the metal edges. Moreover, the tendons have to attach to bone, which means the fishing line will have to come in contact with metal at some point. This can be achieved by tying a fishing line to the distal phalanx. Then that line can be run along the inside of the middle phalanx, around the middle and proximal joint, and finally outside of the proximal phalanx. Similarly, a second fishing line can be tied to the knot of the first fishing line, run on the opposite side of the middle phalanx, run around the middle and proximal joint, and then run outside of the proximal phalanx. This means that the middle phalanx will need to have two plastic channels for the tendons to run through. That can be achieved by creating a core for the middle phalanx that combines the function of the joints and the channels. Basically, the two channels will be subtracted from the height of the middle phalanx, which gives you a connected 5 mm diameter and 10 mm diameter joint in a shape similar to a middle phalanx bone, which is actually a good place to start off with in the construction phase. The construction will require sheet metal, a sheet of plastic, some cardboard, a piece of 16 gauge metal wire, some fishing line, rubber cement, and some tools. A metal can or canister can be flattened for sheet metal. A canister might be under pressure and should be punctured with a punch or similar tool to avoid igniting any combustible gases. A frozen dinner will provide you with both a plastic container for the plastic sheet and the cardboard to make the part templates. The recyclable plastic number 5, polypropylene, can give you a low friction surface that can still be glued together. Use the cardboard to make the core template by drawing the 5mm and 10mm joint circles 20mm apart at their centers with the two radially attached sides. Then use the cutout template to cut about 6 layers of the plastic container to make the core. The 6 layers should be about 3mm thick when stacked on each other. Glue them together at their centers to avoid interfering with your drill bit. Drill a 2mm hole, that's about 5/64 of an inch, in the center of each of the joint circles. If you have a soldering iron with a plastic welding tip, you can use it to smooth out the edges of the 6-layered core. You basically want to keep the layers from splitting apart from the force of the fishing line rubbing against it. The next template will be for the metal layer of the middle phalanx. Draw a 10mm and 15mm diameter circle with their centers 20mm apart. Make a mark 14mm from the center of the 10mm circle and cross it with a mark 26mm from the center of the 15mm circle. Make this the center of a 10mm circle. Then make a mark 20mm from the center of the new circle and cross it with a mark 19mm from the center of the 15mm circle. This cross will be the center of a second 15mm circle. Next, connect all 4 circles by drawing a 4mm by 20mm rectangle in the middle of them. Center the core template in between a 10mm and 15mm circle to draw an outside line from the 10mm circle to the 15mm circle. Repeat this process with the other 10mm and 15mm circle. Cut out this bone-like shape as the metal layer template for the metal phalanx. Now cut the metal to shape using the template and drill a 2mm hole at the center of each of the circles. Clean up and round off the metal edges with a file to prevent cuts. Fold the metal along the 4mm by 20mm rectangular center, creating a 3mm gap for the core. One more plastic layered template is needed for the middle phalanx, so draw a rectangle 5mm by 11mm. Take the metal template and align the outside of it to the rectangle. Then trace the 10mm and 15mm circles of the metal template. Do this on both sides of the rectangle. Connect the sides of the circles and cut out the plastic shape. Clean up the edges, drill 4 2mm holes in the center of the 2 10mm and 2 15mm circles. Fold along the 5mm by 11mm rectangular center to create a 4mm gap. The distal phalanx template is a simple design. Draw 2 10mm circles centered 15mm apart from each other. Draw a line between the 2 centers and use it to make a 5mm by 20mm rectangle in the middle of the 2 circles. In the middle of the rectangle, make a mark centered 7mm down from the previous line and another 6mm down from that one to show the drill points. Draw a line 3mm straight out from both sides of the rectangle's base, making the base an 11mm line. Draw 2 lines connecting the ends of the 11mm base line to the outside of the circles. Cut out the middle shape and drill 2mm holes in the center of the 2 circles and 2mm holes at the 2 centered marks. Clean up and round off the middle edges with a file to prevent cuts. Bend the metal along the 20mm edges of the center rectangle to create a 5mm gap. The proximal phalanx design will be the socket for the stump. The socket will be made of metal, so the design will need to include a sock or similar covering to allow airflow and to reduce the tissue damage to the stump. For this video, the stump will be a glove-covered distal filix. The stump is measured by wrapping a 70mm by 40mm piece of cardboard around it and marking the overlap. The mark is then used to divide the cardboard into 4 equal rectangles and an overlap piece lengthwise. Draw a 15mm circle at the top of every other rectangle for the 2 joints. Then draw a line 16mm from the top of the cardboard just under the 2 circles and across the rectangles. Next, draw a line 7.5mm from the top of the cardboard straight through the centers of the 2 circles. Finally, cut the cardboard starting at the 7.5mm line to the first circle. Cut around the circle to the 7.5mm line, across the 7.5mm line to the second circle. Cut around the second circle to the 7.5mm line and then to the edge. Then make an incision along the line from the 7.5mm cut to the 16mm line on the outside of the first circle, skipping the cardboard in between the 2 circles, and then another incision from the 7.5mm cut to the 16mm line on the second circle. Cut out the metal shape and drill 2mm holes in the centers of the 2 circles. Drill a 2mm hole 1mm below the 16mm line centered between the 2 circled topped columns. Clean up and round off the middle edges with a file to prevent cuts. Bend the overlap piece on the line started by the 7.5mm to 16mm incision. Do the same to the rectangles started by the 7.5mm to 16mm incision. Grab both bent ends to wrap the metal into a tube shape, while covering the overlap piece with the rectangular end. Tape the whole thing together. Using the 2 incisions, bend the newly formed rectangular flat surface at the 16mm line until the flap lies flat. Squeeze the 2 15mm circles at the 7.5mm line to form a 9mm gap. A spacer will be needed to fill the 4mm difference between the socket's 9mm gap and the 5mm width of the middle filix. So draw 2 15mm circles with their centers 22mm apart. Then draw 2 parallel lines connecting the tops and bottoms of the 2 circles. Use this template to cut an oval shape in the plastic. Drill 2 2mm holes in the centers of the 2 circles and smooth all the edges. Cut out 4 15mm circles with 2mm holes in their centers and glue them to the circles of the oval. Then bend the oval to make a 5mm gap. Cut 60mm of the 16 gauge wire and bend it at the 25mm and 45mm marks along its length. Verify that the wire fits into both of the core's 2 holes at the same time. Repeat this for the metal layer and the plastic layer of the middle filix before beginning the assembly. This will be the retaining wire. To assemble, the fingers start by wrapping the metal middle filix layer over the core, making sure the holes are aligned and that both are facing the same direction. Next, wrap the plastic layer over the metal layer from the opposite side, making sure the holes are aligned and that the core is not visible from either side. Then fold the spacer over the 15mm end of the 3 middle filix pieces and insert it into the metal socket. Take the 25mm end of the bent retaining wire and insert it into the socket's hole through the spacer, plastic layer, metal layer, and core. It should be visible from the other side before the 15mm end of the wire is even inserted. Run some of the fishing line through the 2 holes in the fingernail part of the distal filix and tie it to itself to form a loop. Tie a second piece of the fishing line to the loop on the joint side and tighten the loop until it is no longer visible. Separate the two lines so that one is above and the other one is below the joint, and slide the distal phalanx over the middle phalanx. Align the holes and insert the 15mm end of the retaining wire, sliding both ends of the wire completely through the layers. With the finger extended, run the lower fishing line through the bottom gap between the core and the plastic layer of the middle phalanx. Then run it in between the large end of the core and the 15mm spacer and continue through the socket's 2mm hole. Pulling on the line should make the finger curl. Now run the upper fishing line in between the core and the middle layer of the middle phalanx. Then run it in between the large end of the core and the 15mm spacer in the opposite direction of the previous line. Pulling on this line should extend the finger. At this point, I would like to give you some options before finishing the construction. The first option would be to use elastic to extend the finger instead of using a second fishing line. Just like the fishing line, you would tie one end of the elastic to the loop of the distal phalanx and then tighten the loop. The 2mm hole in the center of the proximal socket should be increased to 3mm so you can tie the second end of the elastic through it. You would then need to assemble the middle phalanx around the elastic before inserting the 16-gauge retaining wire. One problem with this option is that the elastic has to be strong enough to extend the finger several times without breaking. The second option would be to run the second fishing line through the socket's 2mm center hole and then to tie it to an extension spring. The biggest problem with this option is mounting the spring in a place that remains the same distance from the socket when the proximal phalanx stub moves. The third option is to modify the proximal socket to limit the movement of the middle phalanx. An arch over the middle phalanx was formed after squeezing the two 15mm proximal socket joints together. This arch allows the middle phalanx to rotate past the point of full extension. To solve this, you could just bend the arch into an M shape. If you use the elastic option or mount something in the arch, this option will not be necessary. The fourth option is to use the retaining wire to limit the movement of the middle phalanx. With the finger in the extended position, bend the 25mm end of the wire up towards the proximal socket's arch. Then bend about 3mm of the end of that wire so that it touches the base of the arch. Then bend the 15mm end of the retaining wire towards the 25mm end. If you are not using the fourth option to finish the construction, then just bend both of the ends of the retaining wire towards each other. Finally, to use the prosthetic finger, the fishing line should be attached behind the knuckle so that the line has to travel around the knuckle when the hand is in a fist. The second fishing line should be attached at the palm near the base of the socket.